Okay, this is a little synopsis of lesson 27.1, polar coordinate system. Okay, and by the way, the correct answer to this problem right here is B. Yeah, if you divide x minus x equals to 3t, divide that by 3, you're going to get that x is equal, t is equal to x over 3, and so you just substitute that in, and that gives you the result of B. Okay, all right, let's get into the lesson. Okay, so at the end of this lesson, you should be able to graph polar coordinates, and you should be able to convert polar coordinates to rectangular coordinates and back and forth. Okay, so look at the difference between the rectangular coordinate system and the polar coordinate system. Okay, just study the screen and notice that with a rectangle you have an x and a y axis. With the polar coordinate system, you have a radius and you have an angle. We call it the origin for the rectangle, and we call it the pole for the pole. So the key to graphing polar coordinates is to graph the angle first, then the radius. Positive theta moves counterclockwise, negative theta moves clockwise. A positive radius r is the terminal side, and a negative r radius is the opposite of the terminal side. So let's say we were going to graph the polar coordinates 2, 45. First thing you're going to do is circle the 45-degree angle where it is, and then go to the origin and draw a radius of length 2. And in this particular one, it didn't reach all the way to the 2, but it should. Should have stopped right here on that second circle. But notice that you draw the radius, you circle the angle first, and then you draw the radius on the line that connects to that angle. Okay, pointing toward that. Now, what happens if the radius is negative? Well, you still circle the angle, but this time you draw the line going away from the angle, and you make sure it is 3.5 radii in length. Okay, and there's a few more practice problems here. Okay, all right, I will skip this right now. Okay, the second thing we're going to learn how to do is convert polar coordinates to rectangular coordinates. So let's say we wanted to convert 245 to polar coordinates. Okay, to rectangular coordinates. All right, the first thing you got to realize is that you got to pick out what r is. R is 2, and theta is 45 degrees. Okay, we know that. So to figure out to convert to x, you got to multiply r times the cosine of the angle. So 2 cosine 45 degrees is equal to 2 times the square root of 2 over 2. You get that from the unit circle. And then the 2's cancel out and you end up with the square root of 2. Same thing for y. Alright, well that gives you 2 for the x, square root of 2 for the x. And then same thing for the y. 2 sine 45 degrees, 2 times the square root of 2 over 2, that's the sine of 45 degrees. 2's cancel out, you end up with the square root of 2. So we have converted 2 45 degrees polar form to rectangular form, square root of 2, square root of 2. Okay? All right, there are some practice problems there. Now let's look at how to convert rectangular coordinates to polar coordinates. Okay, so let's say you're given the rectangular coordinate 1 negative square root of 3. Well, use r equals to the square root of x squared plus y squared. If you do that, 1 squared is 1. The negative square root of 3 squared is just 3. 1 plus 3 is 4. Square root of 4 is 2. So that tells us what r is, 2. For theta, then we use one of these two formulas. Notice that x is positive. So we use the first formula. The tangent of the inverse tangent of y over x, y is the square root of 3 over 1. Y over x is the square root of negative square root of 3 over 1. That is simplifies to the square root of negative square root of 3. If you take the inverse tangent of that, the calculator gives you a negative 60 degrees, which you have to add 360 degrees to it to get the coterminal angle, and you end up with 300. And so, and there's some more practice examples. Okay. Feel free to cycle through this video to see more examples. So at this point, you should know how to graph polar coordinates, and you should know how to convert polar coordinates to rectangular coordinates. That ends the video.